Lesson number 16, Light. The world is largely known through the senses. The sense of sight is one of the most important scenes. Through it we see mountains, rivers, trees, plants, stairs, people, and so many other things around us. We also see clouds, rainbows, and birds flying in the sky. At night, we see the moon and the star. You are able to see the words and sentences printed on page. How is seeing made possible? 16.1 What makes things visible? Have you ever thought how we see various objects? You may say that I see the objects, but can you see an object in the dark? It means that I when light from an object. The light may have been emitted by the object or may be have been reflected by it. You learned in class 7 that a polished or a shiny surface can act as a mirror. A mirror changes the direction of light that falls on it. Can you tell in which direction the light falling on a surface will be reflected? Let us find out. 16.2 Laws of Reflection. Activity 16.1 Fix a white sheet of paper on a drawing board or a table. Take a comb and close all its openings except one in the middle. You can use a strip of black paper for this purpose. Hold the comb perpendicular to the sheet of paper through light from a torch through the opening of the comb from one side. With slight adjustment of the torch and the comb, you will see a rays of light along the paper on the other side of the comb. Keep the comb and the torch steady. Place a strip of plain mirror in the path of the light ray. What do you observe? After striking the mirror, the ray of light is reflected in another direction. The light rays which strikes any surface is called the incident ray. The ray that comes back from the surface after reflection is known as the reflected ray. Draw lines showing the position of the plane mirror, the incident ray, and the reflected ray on the paper with the help of your friends. Remove the mirror and the comb. Draw a line making an angle of 90 degree to the line representing the mirror at the point where the incident ray strikes the mirror. This line is known as the normal to the reflecting surface at that point. The angle between the normal and incident ray is called the angle of incidence. The angle between the normal and the reflected rays is known as the angle of reflection. Measure the angle of incidence and the angle of reflection. Repeat the activity several times by changing the angle of incidence. Enter the data in table 16.1. Do you see any relation between the angle of incidence and the angle of reflection? Are they approximately equal? If the experiment is carried out carefully, it is seen that the edge of angle of incidence is always equal to the angle of reflection. This is one of the law of reflection. Let us perform another activity on reflection. Activity 16.2. Perform activity 16.1 again. This time use a sheet of strip paper or a chart paper. Let the sheet project a little beyond the edge of the table. Cut the projecting portion of the sheet in the middle. Look at the reflected ray. Make sure that the reflected ray extends to the projected portion of the paper. Bend that part of the projected portion on which the reflection ray falls. Can you still see the reflection ray? Bring the paper back to the original position. Can you see the reflection ray again? What do you infer? When the whole sheet of paper is spread on the table, it represents one plane. The incident ray, the normal at the point of incidence, and the reflected rays are all in this plane. When you bend the paper, you create a plane different from the plane in which the incident ray and the normal lie. Then you do not see the reflected ray. What does it indicate? It indicates that the incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. This is another law of reflection. Paheli and Bujo performed the above activities outside the classroom with the sun as a source of light instead of a torch. You too can use the sun as the source of light. Bujo remembered that in class 7 he had studied some features of the image of an object formed by a plane mirror. Paheli asked him to recall those features. Was the image erect or upside down? Was it of the same size as the object? Did the image appear at the same distance behind the mirror as the object was in front of it? Could it be obtained on a screen? Let us understand a little more about the formation of an image by a plane mirror in the following way. Activity 16.3. A source of light O is placed in front of a plane mirror PQ. Two rays OA and OC are incident on it. Can you find out the direction of the reflected rays? Draw normals to the surface of the mirror PQ at the points A and C. Then draw the reflected rays at the point A and C. How would you draw these rays? Call the reflected rays AB and CD respectively. Extend them further. Do they meet? Extend them backwards. Do they meet now? If they meet, marks this point as I for a viewer I at E. Do the reflected rays appear to come from the point I, since the reflected rays do not actually mean at I, but only appears to do so. We say that a virtual image of the point O is formed at I. As you have learned already in class 7, such an image cannot be obtained on a screen. You may recall that in an image formed by a mirror, the left of the object appears on the right and the right appears on the left. This is known as lateral inversion. 16.3. Regular and diffuse reflection. Activity 16.4. Imagine that parallel rays are incident on an irregular surface as shown in Fig 16.6. Remember that the laws of reflection are valid at each point of the surface. Use these laws to construct reflected rays at various points. Are they parallel to one another? You will find that these rays are reflected in different directions. When all the parallel rays reflected from a rough or irregular surface are not parallel, the reflection is known as diffused or irregular reflection. Remember that the diffused reflection is not due to the failure of the laws of reflection. It is caused by the irregularities in the reflecting surface like that of a cardboard. On the other hand, reflection from a smooth surface like that of a mirror is called regular reflection. Images are formed by irregular reflection. 16.4. Reflected light can be reflected again. Recall the last time you visited a hairdresser. She or he makes you sit in front of a mirror. After your hair is cut completely, she or he holds a mirror behind you to show you how the hair has been cut. Do you know how you could see the hair at the back of your head? Paheli recalls having constructed a periscope as an extended activity in class 6. The periscope makes use of two plane mirrors. Can you explain how reflection from the two mirrors enable you to see objects which are not visible directly? Periscopes are used in submarines, tanks, and also by soldiers in bunkers to see things outside. 16.5. Multiple images. You are aware that a plane mirror forms only a single image of an object. What happens if two plane mirrors are used in combination? Let us see now. Activity 16.5. Take two plane mirrors, set them at right angles to each other with their edges touching. To hang them, you can use adhesive tape. Place a coin in between the mirrors. How many images of the coins do you see? Now, hang the mirrors using the adhesive tape or different angles, say 45 degree, 60 degree, 120 degree, 180 degree, etc. Place some object in between them. Note down the number of images of the object in each case. Finally, set the two mirrors parallel to each other. Find out how many images of a candle placed between them are formed. Can you now explain how you can see the back of your head at the hairdresser shop? This idea of number of images formed by mirrors placed at an angle to one another is used in a kaleidoscope to make numerous beautiful patterns. You can also make a kaleidoscope yourself. Kaleidoscope. Activity 16.6. To make a kaleidoscope, get three rectangular mirror strips, each about 15 cm long and 4 cm wide. Join them together to form a prism as shown in Fig 16.12a. Fix this arrangement of mirrors in a circular cardboard tube or tube of a thick chart paper. Make sure that the tube is slightly longer than the mirror strips. Close one end of the tube by a cardboard disc having a hole in the center through which you can see. To make the disc durable, paste a piece of transparent plastic sheet under the cardboard disc. At the other end, touching the mirrors, fix a circular plain glass plate Plate Place on this glass plate several small pieces of colored glass. Close this end of the tube by a ground glass plate. Allow enough space for the color species to move around. Your kaleidoscope is ready. When you peep through the hole, you will be able to see a variety of patterns in the cube. An interesting feature of a kaleidoscope is that you will never see the same pattern again. Designer of wallpapers and fabrics and artists often use kaleidoscope to get ideas for new patterns. To make your toy attractive, you can wrap the kaleidoscope in a colored paper. Activity 16.7. Get a plane mirror of a suitable size. Place it in a bowl as shown in fig 16.13. Fill the bowl with water. Put this arrangement near a window in such a way that direct sunlight falls on the mirror. Adjust the position of the ball so that the reflection light from the mirror falls on the wall. If the wall is not white, fix a sheet of white paper on it. Reflected lights will be seen to have many colors. How can you explain this? The mirror and water form a prism. As you learned in class 7, this breaks up the light into its colors. Slitting of light into its color is known as dispersion of light. Rainbow is a natural phenomenon showing dispersion. 16.6. Sunlight, white or colored. In class 7th, you learned that the sunlight is referred to as white light. You also learned that it consists of 7 colors. Here is another activity showing that sunlight consists of several colors. 16.7. What is inside our eyes? We see things only when light coming from them enters our eyes. Eye is one of our most important sense organ. It is therefore important to understand its structure and working. The eye has a roughly spherical shape. The outer coat of the eye is white. It is tough so that it can protect the interior of the eye from accidents. Its transparent font part of is called cornea. Behind the cornea, we find a dark muscular structure called iris. In the iris, there is a small opening called the pupil. The size of the pupil is controlled by the iris. The iris is the part of eye which gives it in distinctive color. When we say that a person has green eyes, we refer actually to the color of the iris. The iris controls the amount of light entering into the eye. Let us see how. Activity 16.8. Look into your friend's eye. Observe the size of the pupil. Throw light on her eye with a torch. Observe the pupil now. Switch off the torch and observe her pupil once again. Do you notice any change in the size of the pupil? In which case was the pupil larger? Why do you think it was so? In which case do you need to allow more light in the eye when the light is dim or bright? Behind the pupil of the eye is a lens which is thicker in the center. What kind of lens is thicker at the center? Recall what you learned about lenses in class 7th. What kind of lens is thicker at the center? Recall what you learned about lenses in class 7. The lenses focuses light on the back of the eye on a layer called retina. The retina contains several nerve cells. Sensation felt by the nerve cells are then transmitted to the brain through the optic nerve. There are two kinds of cells: cones, which are sensitive to bright light, and rods, which are sensitive to dim light. Cones sense color. At the junction of the optic nerve and the retina, there are no sensory cells, so no vision is possible at that spot. This is called the blind spot. Its existence can be demonstrated as follows. Activity 16.9. Make a round mark and a cross on a sheet of paper with the spot to the right of the cross. The distance between two marks may be 6 to 8 centimeters. Hold the sheet of paper at an arm's length from the eye. Close your left eye. Look continuously at the cross. Move the sheet slowly towards you, keeping your eye on the cross. What do you find? Does the round mark disappear at some point? Now close your right eye. Look at the round marks now and repeat the activity. Does the color disappear? The disappearance of the color or the round marks shows that there is a position on the retina which cannot send messages to the brain when light falls on it. The impression of an image does not finish immediately from the retina. It persists there for about 1/16th of a second. So if still images of a moving object are flashed on the eye at a rate faster than 16 per second, then the eye perceives the objects as moving. Activity 16.10. Get a square piece of cardboard of size 6 to 8 centimeter. Make two holes as shown in Fig 16.16. Thread a string through the two holes. Draw or paste a cage on one side of the cardboard and a bird on the other side. Twist the string and make the card twirl rapidly. Do you see the bird in the cage? The movies that we see are actually a number of separate pictures in proper sequence. They are made to move across the eye usually at the rate of 24 pictures per second. So we see a moving picture. Nature has provided eyes with eyelids to prevent any object from entering the eye. Eyelids also shut out light when not required. Eye is such a wonderful instrument that it can clearly see distant objects as well as objects nearby. The minimum distance at which the eye can see objects distinctly varies when with age. The most comfortable distance at which one can read with a normal eye is about 25 centimeters. Some persons can see objects close to them clearly but cannot see distant objects so clearly. On the other hand, some person cannot see objects nearby clearly but they can see distant objects quite well. With suitable corrective lenses, these defects of the eye can be corrected. Sometimes, particularly in old age, eyesight becomes foggy. It is due to the eye lens becoming cloudy. When it happens, persons are said to have cataract. There is a loss of vision, sometimes extremely severe. It is possible to treat this defect. The opaque lens is removed and a new artificial lens is inserted. Modern technology has made this procedure simpler and safer. 16.8. Care of the eyes. It is necessary that you take proper care of your eyes. If there is any problem, you should go to an eye specialist. Have a regular checkup. If advised, use suitable spectacles. Too little or too much light is bad for eyes. Insufficient light causes eye strains and headaches. Too much light, like that of the sun, a powerful lamp or a laser torch can injure the retina. Do not look at the sun or a powerful light directly. Never rub your eyes if particular particles of dust go into your eyes. Wash your eyes with clean water. If there is no improvement, go to a doctor. Always read at the normal distance for vision. Do not read by bringing the book too close to your eyes or keep it too far. You learned about balanced diet in class 6. If food is deficient in some components, eyes may also suffer. Lack of vitamin A in foodstuff is responsible for many eye troubles. Most common amongst them is night blindness. One should therefore include in the diet components which have vitamin A. Raw carrots, broccoli, and green vegetables and cod liver oil are rich in vitamin A. Eggs, milks, curd, cheese, butter, and fruits such as papayas and mangoes are also rich in vitamin A. 16.9. Visual impaired persons can read and write. Some persons, including children, can be visually impaired. They have very limited vision to see things. Some persons cannot see at all since birth. Some persons may lose their eyesight because of a disease or an injury. Such persons try to identify things by touching and listening to voice more carefully. They develop their other senses more sharply. However, additional resources can enable them to develop their capabilities further. 16.10. What is the Braille system? The most popular resource for visually challenged person is Braille. The present system was adopted in 1932. There is Braille code for common language, mathematics, and scientific notations. Many Indian languages can be read using the Braille system. Visually impaired people learn the Braille system by beginning with Braille system by letters, then special characters and letter combinations. Method depends upon recognition by touching. Each character has to be memor- memorized. Braille text can be produced by hands or by machine. Typewriter-like devices and printing machines have now been developed.